All right, so let's look at day 2 of 3-8, and this is our last lecture before the test. Your test is on Thursday. So you might want to start studying today. You can go to Pearson Success.net and start taking the lesson quizzes and the chapter tests. I will tell you your test is multiple choice this time. You might want to be practicing the multiple choice questions. So it would be hugely to your advantage to start that tonight. Kind of work your way through those. So whatever section you feel that you're the weakest on, that's where I would concentrate. Okay, so we stopped at problem 2. Today we're going to focus on perpendicular lines. So we already kind of had an introduction to that when we we're going over notes or homework. But your perpendicular lines, and I'm missing my highlighter, hold that thought. All right, so if two non-vertical lines are perpendicular, meaning they can't look like this, because what is the slope of the horizontal line? Everybody, what's the slope of the horizontal line? Can you walk on it? 0. So you can walk on it. It has a slope of 0. It has no incline. What's the slope of the vertical line? Undefined. You cannot take 0 and multiply it to undefined. And so that's why they're saying two non-vertical lines are perpendicular, then this is the key point, the product of their slopes is -1. And of course then they have the converse, if the product of the slopes of two lines have a product of -1, then the lines are perpendicular. Any horizontal line and vertical line are also perpendicular, because they don't fall into that category. And really, when I go back to that definition we had yesterday, where perpendicular slopes are opposite signs and reciprocals. Oops, can't see that. So if I said that the slope is equal to 1/3, we're just looking at a line whose slope is 1/3. What would be the perpendicular slope to 1/3? Yeah, the opposite sign is negative. The reciprocal of 1/3 is 3. What if I gave you this slope is equal to -5? What is the perpendicular slope to -5? Opposite sign is positive, right? And the reciprocal of 5/1 is 1/5. What's the parallel slope to 1/3? 1/3, right? The trick question. And what is the parallel slope to -5? -5. The parallel slopes are the same. Perpendicular slopes are opposite signs and reciprocals. So you have to do two things to get that perpendicular slope. So problem number 3. Line 3 contains points A and B. Line 4 contains points C and D, so we know all values of all 4 ordered pairs. Are 3 and 4 perpendicular? So in order to determine if they're perpendicular, what do you need to know? Their slope. So we're going to find the slope of each line. So please find the slope of each line. I'll let you do that on your own. Make sure that you start with your template. Right? And if I were you, I'd be labeling your points as x sub 1, y sub 1, x sub 2, y sub 2, x sub 1, y sub 1, x sub 2, y sub 2. I bet you can. Even if it doesn't multiple choice, I still look for the word. You don't have the word, you don't prepare for the answer. So compare your answers to those around you. All right, so what'd you get for the slope of line 3? What'd you get? -8. What'd you get for the slope of line 4? Now you might have reversed your numbers, but overall, so you might have had 8 over -1, but we still would get a -8. And you might have had -1 over -10, but that reduces to a positive 1/10. It doesn't matter what order you put the points in, but remember the points have to be vertical to each other. They cannot be diagonal to each other. So the order that you choose X and Y is important. Are they perpendicular? No, because if I take -8 and I multiply it to 1/10, 2 goes into 8 and 10, so 2 goes into 8, -4, 2 goes into 10 5 times, I get an answer of -4/5, which is not, bless you, -1. So therefore, lines 3 and 4 are not perpendicular because the product of their slopes does not equal -1. You'll have some questions like that, and it could be a line in a coordinate grid, or 2 lines in a coordinate grid that you're trying to determine if they're perpendicular. You have to stair step and find the slopes of the lines and compare them. Are they opposite signs of reciprocals? All right, then problem 4. What is the equation of the line perpendicular to y equals -3x minus 5? So this is not the line we're seeking. This is the line that our line is perpendicular to. That contains this point. So just like yesterday, we're going to use this line purely for the slope. What is the slope of this line? -3. What is the perpendicular slope? Because our line is perpendicular. Change the sign positive, find the reciprocal 1/3. So I'm going to use the perpendicular slope and this point. This point is x sub 1, y sub 1. So then we're going to use point slope form. So we've got down here, we're using that slope of positive 1/3. I don't care about any of that. So let's go ahead and plug into the formula down here. So y minus and x minus. So I'm putting in for y sub 1, 7. We're putting in for our slope, positive 1/3. And for x sub 1, we're putting in a -3. You have to take care of all double signs, so plus plus. Boys, why aren't you following along with me? I asked you already to take notes today. This is not an observation class, it is a participation class. So then you want to distribute your 1/3. So we get y minus 7. I can't add that 7 until I clear those parentheses. So 1/3 times x is 1/3 x. What's 1/3 times positive 3? Positive 1, which is nice because we don't have to deal with fractions. Add your 7. And we get y equals 1/3 x plus 8. Then look at your original line with this line. The slope of this line is -1/3. The slope of your line is 1/3. Are they perpendicular slopes still? And all of a sudden, and then, of course, you could always plot them if you wanted to check and see do they appear to be perpendicular. Last problem. I want you to answer those questions 24 and 25. didn't answer, I want you to share it with those around you. So talk to those around you. Everybody should be talking. Mariah, chat with Zoe. Okay, so stop. Where was the error? Parallel lines have the same slope. Not only did they, I mean, is that even the slope of a perpendicular line? No, they didn't. So they weren't even thinking perpendicular, because they just took a reciprocal. But you're right, parallel lines have the same slope. So should this have been the proper word? They put the ordered pair in the correct places, but the slope was wrong. Issue problems are concerned with that. Okay, so let's look at your workbook. So turn to page 87. We're just going to do a couple of problems. So I want you to look at, this is page 87. I want you to look at number 7. I want you to stair step that slope. So you're going to create a stair, either above, a step either above or below. So I'm going to choose here. Here's my right angle. Find your rise and your run. Remember, your rise is vertical, your run is horizontal. And do the same thing for this line. So I'm going to choose, put my stair here. And then I want you to compare the slopes. Determine if those lines are perpendicular. You can't just look at the picture and go, nope, they don't look perpendicular. You have to prove it. So find the slopes of each of those lines. And I wouldn't even do it algebraically, I would just count the squares. Chat with those around you, see what they think. Skylar, Jessica, chit chat with each other. Danny, who'd you got? Don't really love me now. So are the lines perpendicular, yay or nay?
Nay.
Nay. Nay is the correct answer. Nope. So you've got this line is -4/5, correct? And this one is +3/2. Make sure if you have two negatives that you do reduce. When you look at the fully reduced fraction. What would be the perpendicular slope to -4/5? 5/4, +5/4. What about this one? -2/3. All right, then I want you to do question number, we'll do 12. So just like example, what was it that we did on the back? So if you want to have opened up example number 4, this is just like example number 4 on your notes. So follow that, you're going to do number 12. chose this one specifically for the ugly fractions. So when you add that 5 at the very end, you've got to put over 1 and find the least common denominator. So we're changing both fractions to least common denominator. So what's the slope that you should be using? 4/7, right? Because if the slope there is negative 7/4, the opposite sign is positive, and the reciprocal is 4/7. So you should be using 4/7.
Let's just say kind of explain something because we like that idea of teaching and so it's the hardest part. So you have to do different what do you just great that's where I got you. Multiple set of people and more
Okay, so what did we get for our y-intercept? We're stumped? Is it because of the fraction? Okay. Fractions are friendly. Yeah, you guys freeze up when you see fractions. So let's look to see what I did. So we start here with the slope of this line is negative 7/4. Right? The opposite and reciprocal is at 4/7. And then we have our x sub 1 and y sub 1. So all I did was take the point slope form and I plugged in those numbers. So here's your 4/7 for your slope, and here's your 2 5s for your x and your y. When you distribute, you have to distribute the 4/7 first. You cannot add a 5 without distributing. You can't add a 5 to something that's in parentheses. So you get 4/7 x here. Positive times a negative is a negative. If you look here, nothing cancels. So you've got 4 times 5 is 20. 7 times 1 is 7. Then when I go to add that 5, well, I have to add 5 as a fraction over 7. So 5 over 1, least common denominators between 7 and 1 is 7. So I multiplied this denominator by 7 and this numerator by 7. And I get 5 times 7 is 35. 1 times 7 is 7. And this stays negative 27ths. Now I have like denominators. Now I can just focus on the numerators. Your numerators are opposite signs. Don't you subtract and keep the sign larger? So I subtract 20 and 35 and I get 15. 35 is bigger, so I get a positive 15 over 7. Don't change it into a mixed number. Can't stand them. No decimals. So make sure that tonight you're paying attention to whether you are doing perpendicular lines versus parallel lines, because your slope is all that matters. All right, so flip page. Let's look at 14 and 15. So you're to rewrite each equation in slope-intercept form, then determine whether the lines are parallel. I cannot determine whether these two lines are parallel until both lines are solved for y. Because once they're solved for y, I can see the slopes. Alright, so then, what do I have to do to this equation to solve for y? Divide everything by 2. So if I divide both sides by 2, that means I divide every term by 2. So then this one becomes y equals, take the x out of the fraction. What do you have? 1/2. So it becomes 1/2 x and then just write it as 15 halves. We don't really care about the y-intercept when we're comparing slopes. Then this one is not solved for y yet. So for this one, I need to get the y term by itself, don't I? So do I want to subtract the 5? So I'm going to put the 2y on the left because that's where I like to have my y term. And if I subtract the 5, don't I have x minus 5? I really use the symmetric property at the same time, don't I? So 2y is by itself, so I put by itself on one side, and if I subtract the 5, I get x minus 5 on the other side, so I put that on the other side. You could subtract the x, but then you'd have to subtract the 2y. Yep. But then I don't like to go with negatives, so that's why I chose not to do that, but yes, you could. Now how do I solve the y? Let's see. Then divide everything by 2. If you're dividing both sides by 2, when you divide this side by 2, everything is divided by 2. That's true. And so we end up with y equals, take x out of the fraction. What do you get? 1/2 x, and then minus 5 halves. Compare the slopes. Are they the same or different? So are they parallel? So yes, they're parallel. So then I want you to solve 15. Determine if 15 is parallel. Don't let the big numbers fool you. It's actually fairly simple. So on a problem like this, where it's a yes-no kind of answer, there are actually two parts to your answer. Yes, you get credit for the yes or no, but the second part is because you will support that yes or no. If you don't have a direct equation to support the word, you just want the word. You might luck into the answer. So comparing answers with something like this. All right, so let's look at these. So for the top one, I subtracted 130 from both sides to get that y term by itself. So I get 10y equals 50x. I put the minus 130 on the right side because that's where the y-intercept would go. And then to solve for y, I divided everything by 10, which is nice because 10 evenly goes into everything. So you get a 5x and a minus 13. So the slope here is 5. Then on this one, all you have to do is divide by a negative, but you have to watch the signs. So dividing by a negative, I get y. Take the x out of the fraction, don't you get a negative 2/5 x? A positive divided by a negative is an overall negative, so it shouldn't be a plus minus. It needs to be a negative. 11 over 5 doesn't reduce. Compare their slopes. Are they parallel? So the answer here is no. The last one that we're going to do, we'll do together. They've got some of these in slope intercept, or I'm sorry, point slope form. Don't let that bother you. Still solve. So we're going to get this equation. We're going to get the y by itself. But this time we're looking to see if they are perpendicular. So again, make sure that you're paying attention whether it's perpendicular versus parallel. So to get y by itself, I'm going to add 1 to both sides. So this one gives me y equals, the 1's cancel. I get a negative x, negative 6, and a positive 1 gives you a negative 5. What's the slope for this one? Negative 1. And then on this one, I have to distribute the negative 5, 6 first. So I get y minus 3 equals negative 5, 6. We still continue to not take notes. Really? It's not go over well with me at all. So I get negative 5, 6x. A negative times a negative is a positive. When I multiply the 5, 6 to the 5, this 5 is over 1. 5 doesn't cancel with 1. 5 doesn't cancel with 6. So you've got to do 5 times 5 is 25 over 6 times 1 is 6. Then when I add 3 to both sides, I have to add 3 as something over 6. So what's the least common denominator between 6 and 1? 6. So this gets multiplied by 6 and this gets multiplied by 6. So I'm really looking at 25 6 here, and 3 times 6 is 18 over 6 here. They're both positive, so adding to the sign. I mean, technically I really don't have to go too much further. I really don't think that's slow. But this gives us y equals negative 5 6x, and I get a positive 25 and 18, 43 over 6. So the slope here is negative 5 6. If I multiply those two slopes together, do I get a negative 1? What would have been the perpendicular slope to negative 1? 1 is its own reciprocal, isn't it? So it would have been positive 1. What would be the perpendicular slope to negative 5 6? Positive 6 over 5. Sign and flip it. All right, questions in general? Okay. So do tonight's homework, just don't do the last problem.